Ladies and gentlemen, boys and girls, and those of you still confused, namely Thomas and Mike and Jimmy, the three of you know who you are. But anyway, what we are doing tonight, if you did not catch the last video, we are building a rotary three-phase converter to power a big Keller power hacksaw that I brought home from an old paper mill. Now what we are doing, as a brief recap, we're taking a 1/4 horse pony motor. This is off of an old Delta drill press I had that was hardly used, but the arbor, somebody gave it to me because they bent the arbor and couldn't find replacement parts. We're going to use this to kickstart this three-phase 5-horse idler motor. So what's going to happen, what we need to do is, we need this to run momentarily just to get this spinning so that we can start generating power. How we are going to accomplish that is I have a little starter switch right here that all we'll do when we press it on, push it in with our finger, that motor should get running. We let it off, it releases power. At that point, that three-phase motor should be churning. Now you could get away, you could do that with a start capacitor setup. For me, this is just as simple. I don't have any potential relays to worry about. I don't have to worry about a start capacitor. So I deal with potential relays quite a bit in refrigeration land. When you're dealing with single-phase compressors, you have potential relays and current relays that help keep that going. What happens when you have a potential relay that goes out, a lot of times they will take a motor or compressor or whatever they're hooked to out with them because they left the start winding engaged way too long and it fries the windings inside the motor. So that's why I'm not doing that setup. Now I'm not saying not to do that setup, to each their own. For me, I've seen it too many times. I'm going to keep it a little simpler. Now moving on, so we're going to use this relay right here. This is going to power the pony motor. Now this is a double throw relay, two pole double throw relay. It has a 12 full load amp capacity on it. That's only a 3.2 amp motor on that guy. So we should be safe with this. This is also a 120 volt coil. Moving along, we're going to use this 2-pole contactor right here to power up the idler motor. Once that idler motor gets running and we are generating our three-phase, we're going to use this 3-pole 120 volt coil contactor to power the bandsaw itself. A lot of this will make a lot more sense as we go. Also, to help clean up that third leg of voltage to balance everything out, because we're going to use some 370 volt 80 microfarad run capacitors. These are oil filled, they're not the electrolyte filled that like to wear out. If you're going to do something like this, get the oil filled, you're going to be a lot happier with it. So this one's so much bigger because this is meant for a condensing unit. So what it'll do, it has a common, it'll run the compressor, and it'll also run a condensing fan. You could actually wire that compressor and the fan in series to get you a little more juice out of it. This one is so you could get 85 out of it altogether. But the part we're looking for is going to be the compressor end of it. That's going to get us our 80 microfarad. This is the same deal, 80 microfarad. These are used, but I did meter them out. There's nothing wrong with them. They meter out just fine. A couple other things. We're just going to use a couple of toggle switches I picked up at the auto parts store to run the coil voltage, the control voltage for the contactors. I'm having a hell of a time talking tonight. So, let's get into it. Let's get some of this stuff mounted. We'll start getting things wired up. Once I get the control box kind of where I want it, we'll take it off of here and we'll wire up the motors. Alright, so I'm going to try to do this. This is going to be kind of hard to run the camera and do this at the same time because my hands are going to block the shot a lot. So we're going to, hopefully we can avoid doing a lot of that. So I'm going to mount my control components in here first. Now this box right here, this side is actually going to be facing up when we stand this thing up. Just seemed the easiest way for me to mount this. I've got it mounted onto a piece of 1/4 inch plate steel on this frame. Nothing real fancy to it. So all I'm going to do, now this is going to be a long one guys, but I tell you what, I do not see many videos on this out there where it's actually explained where a normal human being could actually go and do this. Now remember the message from last night. If you do this at your own risk. This has nothing to do with me. So there's our public service announcement. So what we have here to explain a pilot duty relay for you. We have a coil right here. This kind of works like a contactor coil. So this coil, these are your leads for the coil. That's your actual coil right there. It creates a magnetic field. It pulls in your contacts. Now since these are double throw, when you energize this coil, you're going to have one side of the coil that's open and you're going to have one side of the coil, or the contacts that are closed, excuse me. When you take power off, one set of contacts will close. When you put power on, that set of contacts will open up and the other set will close. So right now in a de-energized state, we're going to see if we can cipher what is our normally open and normally closed. Some wiring schematics will show you power in different ways. Some will show you as if the power is on, some will show you as if the power is off. Now a lot of times you can find the disconnect on your wiring diagrams and it will show you, oh help me out guys, it'll show you if the disconnect is closed or not. So I'm just going to use a continuity tester for this. So on this particular relay, 1 and 4 are common. Number 4 here to number 5 shows as normally closed. So we're going to see if that's normally closed when there's power off of it. Okay, so 4 to 5 is normally closed with no power. Up here on terminal number 1, 1 to 2 is normally closed. Without power on this coil, 1 to 3 is open, and 4 to 6 is also open. So when we wire this up, we either want to wire it 4 to 6, or we want to wire it 1 to 3. So let's get this mounted in there. Now I want to lay this control panel out in such a way that it makes sense when you're looking at it. And what I'm going to do is I'm going to start with my relay for the pony motor because that's going to be the first thing that gets energized. Then I want to go with my contactor for the 240 volt because that'll be the next thing. And the last thing is going to be this guy right here, our 3-pole contactor. I am sorry I'm having trouble explaining tonight, talking fluidly. So I kind of like to plan my circuits out a little bit. Like I said, this is a nice and simple box to do it in. So 120 volt coil, we need to carry a hot, which is going to be our 120 volt, and we need to carry a neutral wire in order to make that magnetic field when that coil is energized. Now if you're going to use stake-ons for this, I don't mind stake-ons, but make sure you get the good brand of stake-ons. Don't buy that cheap crap at Hazard Fraught or your local Blows or Home Depot. Go to your electrical supply house and get yourself the decent stake-on brand stake-ons. Reason for that is the other ones suck. They tend to loosen up on you and it's just no good. And it'll drive you nuts when you're troubleshooting and you have a loose stake-on there. And also when you're using stake-ons, you don't need to strip that wire way back here. I like to have my entire wire tucked under that bonnet right there. I'm less likely to have some shorts with it. Now on these coils, the coil it's just a coil of wire. It does not care what side you put your hot on, what side you put your neutral on. It puts the lotion on its skin. That's all it needs to do. Alright, so here's what we have so far. I figure maybe I better turn the camera on before I get so far into the weeds that you guys lose track of what I'm doing. So we're going to start from the left and work our way to the right. First things first, we have the 80 microfarad 440 or 370 volt capacitor. This is a dual run capacitor, so it's actually made for a condensing unit. So the 80 microfarad part would be for your compressor, the 5 microfarad part would be for your condensing fan motor. Over here we have a 80 microfarad 370 volt capacitor, and where these run, so I have a black wire on here, and that black wire actually ties into, it's actually going to tie into L1 once this contactor is pulled in, and then the black wire on this one goes to L2 once that contactor is pulled in. So the black wires there would actually be your common wires to the capacitors, and once it goes through the capacitors on these white wires, now I'm using white and black because that's the colors I have, that all conducts electricity. The colors don't matter as long as you can keep them straight in your head. One thing I won't do, I don't like using green wires because somebody goes to get into that and they're going to think that's a ground and they may think it's safe to grab. Just granted, I should be the only person ever into this, but you just never know. So anyway, before we get off to the weeds, the white wires coming off of the capacitors feed into T3 for the contactor that's going to feed, or L3 that's going to make the T3 that's going to go to our third leg of the three-phase motor, whatever we're powering off of this three-phase. So the reason we have the capacitors in here, you do not need them, but if you want to increase the longevity of the motor that you're going to be running off of this system, if you want to balance your voltage out better, excuse me, if you want to balance out the voltage better, you're going to want to put the run capacitors in there. They're fairly cheap. Like I said, get the oil-filled ones. Do not get the black plastic ones. They won't last very long in a run situation. All right for a start capacitor, but definitely don't get them for a run capacitor situation. So what's going to happen here, we'll go through the order of operations. This relay right here is going to power our pony motor through a intermittent switch. So what will happen is we'll push the switch, the coil on this will energize, we'll make from these terminals to over here to our normally open. And that's the top one is going to power a little indicator light telling me that the pony motor is on. And the bottom one's actually going to power up the actual pony motor itself. The pony motor is 120 volt, so we need to carry a neutral from our panel box to this system, which we will be doing that. So we'll end up feeding this with 4 wires, ground, neutral, and 2 hot legs. So the pony motor kicks on. Once the pony motor kicks on and that motor starts the idler motor, which would be our big 3-phase motor that we're going to use to generate that third leg. Once that pony motor kicks on, that motor gets spinning, I'll flick the switch to energize this contactor. When that makes, it'll actually put power out to that motor. Now, aside from putting power out to that motor, I have to run 2 wires from here to the line side of this contactor, and that's going to be 2 of the legs to run the hacksaw, and then the third leg is actually going to be generated by this, well, help me out. Our third leg is going to come from our idler motor into here, and then it's going to tie into the third leg of the of the hacksaw. It's 2 in the morning. I've been putzing away on this and didn't want to just run the camera so you guys show me make a bunch of connections. So our terminal strip, I'm keeping this block set aside for neutrals. I didn't need that many. Keeping this set aside for L1. This is going to be L2. Right here going in order. This will power up the coil, our 120 volt coil for the pony motor. This will power up the coil for our idler motor, and this will power up the coil for our 3-phase motor that's our load that's coming off of this. Over here, these are going to be our 3 legs of power that's going to go to the hacksaw itself. So I hope I've explained that all right. I know it's, I shouldn't explain stuff when it's this late, but I wanted to do it before I put my switch plate on this side over here. And that'll cover up the capacitors. I want you guys to be able to see that. Alright, so it's pretty hard to see what I was doing in the wiring in the box of that thing. Let me grab my welding rod pointer stick. So here's a very, very, very simplified schematic of what we did here. And this doesn't show all the contactors and everything. That's something, if you guys have questions, get a hold of me and I'll try to answer the best I can. This is just a simplified diagram of how it all goes together and works. You guys know I'm not great at throwing diagrams out to you guys, so here we go. We'll start with the pony motor. The pony motor right here, this is a 115 volt motor. You could use a 240 volt motor, that's fine. So I've got the pony motor running with a momentary switch off of line 1, and I carry neutral from my panel box to run that. Some people might cheat and use the ground as a neutral. I don't like doing that. I want a real neutral, but so anyway, that's how that goes. So you come along, we get to the idler motor. That is the motor that's generating your third leg of power in the system. So what we have, so say these are your 3 legs of your idler motor. So our motor is at least a size and a half bigger than the load we plan to put on it. So I can run up, that's a 5-horse motor on there. I can run up probably safely up to a 3-horse motor. And I think I'm only running a 1.5 horse motor for that hacksaw. So I should have plenty of power here. So you wire your 3-phase motor up like you would any other. Line 1 to T1, line 2 to T2. And T3 is not going to connect to anything. Your motor leads off the idler motor. That's actually going to be the leg carrying that third leg of ghost voltage to generate your 3-phase. You get up to the load motor. Now to make this run, T1 to T1, T2 to T2, T3 to T3. From T1 to T3, you put a run capacitor in. From T2 to T3, you put a run capacitor in. This helps balance the phases out, makes your voltages a lot nicer, balances everything. You can run it without it, but it does some goofy things when you run it without it, and I will show you guys that. I have it set up ready to go right now. Your run capacitors should be from 12 to 16 microfarad per horsepower. So a 5-horse motor, I'm using 80 microfarad run capacitors. 330 to 370 volt, do not go any lower than that. So that's how that guy is. So anyway, once all this is going, you get your pony motor started. That turns the shaft on the idler motor. As soon as the shaft on the idler motor is turning, disengage the pony motor, flip a switch to energize the idler motor with your line 1 and line 2, L1, L2 to T1, T2. This will stay running. Once this is running, it starts generating that power. By the time you get out the other end on your load side, your motor's running, everybody's happy. So let's go out to the phase converter. It is not in the forge, it actually sits near the panel box because that's where the power hacksaw is going. And let's do some meter testing. Okay, so my apologies if this gets a little loud, a little obnoxious. We're going to do some testing. So the pony motor and all that, while it's not super loud, it does make a little bit of noise. So let's go through the start sequence of what we are doing. You can avoid all this stuff with the pony motor and everything with start capacitors, potential relays, like I said. I'm a mechanical guy. I prefer mechanical things. I've seen too much of how that stuff fails over the years. But it would be nice to hit a start button and have everything just take off. But this isn't like it's a big deal. It's not like it's a lot of extra work. For the couple seconds it's going to take me to do this. So let's get going. So I'm going to push this button right here. This is just a starter switch, and all we are doing is energizing the relay coil that's going to take power to our pony motor. Pony motor gets spinning. We can let off. Now we have three-phase being generated. So, let's see what we have on the line side of our, you guys can see that alright. Now this is a true RMS meter. And a true RMS meter, you're going to see millivolt readings, don't get confused with that. So, T1 to T2. 237 volts, T1 to T3, 249 volts, T2 to T3, 263. Now that looks like pretty dirty power, but as you see, we're going to turn a load onto this. I hear how the sound on that changes. Now watch how our voltage actually cleans up. So we're going to go on the load side of this contactor. T1 to T2, 237. T1 to T3, 234. T2 to T3, 241. That's pretty damn good for a homemade jobber. Now let's show you guys some readings. We're going to check each leg to ground, see what we have. And this is where it gets a little goofy. Good ground there. Watch the voltage meter. So 206 volts on our generated leg. 118. 118. Now let's do some fun stuff. We'll turn that off. Hear how that sound changes when we turn the motor on and off? It quiets our one motor down. I will explain that in just a second. Now we also want to check our amp draw on the load motor that we're running. We'll set our meter to AC amps with a clamp-on amp meter. I don't know, hopefully you guys could see this. So one leg we're running 4.6, we'll say. .1. 5.2. That's pretty good. I mean, we're within an amp. That's really good. So let's see. I'll show you guys what this thing does when you take the run capacitors out of the circuit. Now I'm going to disconnect main power. So our capacitors, we're going to go pull these off. Don't touch anything metal, discharge to ground. Now since these are tied together down on the other end over here on that contactor, I'm not worried about having to do that more than once. Always discharge a capacitor to ground. They can hold. Sometimes it takes them a little bit to discharge. These wires are a little bit trickier to get to. Now you guys are going to see how this changes everything. And this is kind of important to show this. Show you guys how important the actual run capacitors are. People will tell you you don't need them, and it will run that motor without them, but it won't take long before you're going to be burning that motor up, especially if you're using an old piece of equipment or something like that where maybe the motor might be a little bit tired already. Now, I guess we better turn the power back on to it, huh? Okay. Now without the run capacitors, you are creating a true ghost phase on this thing. And I will show you exactly how that reads with the amp meter when we get it running. So, start the process. Let it pick up speed. So now we're generating three-phase once again. We're going to check our voltage with no load on it. $236, $211, $203. Check these to ground. Yeah, it must be I didn't have something welded tight enough or something. 119, 118, 170. So we had a substantial voltage drop without the run capacitors. Now remember how when we turned, that's what it is. Let's take this off. It's making too much noise. There we go. That's better. Alright, so we'll get the load going again. Now watch our amp probe. This is where it's kind of interesting. $5.9. $6.2. Look at that. 0.8. We're actually not generating enough voltage on that leg to run that motor properly without the run capacitors. Now we'll check it with our three-phase motor running our voltage. $235, $210, $199. So that's actually pretty close. And yes, folks, it is a little loud, but I will tell you that the noise usually, the camera picks up noise much differently than it is when you're standing right next to it. So we're going to turn the power off. Okay, pardon the mess, guys. Now I'm going to show you how this guy runs on the mechanical side. And this should give you a pretty good indication of what we're doing. So right here, that is our sample load on here. This is a 3 horsepower, 230 volt three-phase motor, or it's wired for 230 volt. We have behind it the bigger motor. That's our 5 horse idler motor. And then that little guy off to the side, that is our 1/4 horse pony motor. That pony motor is really the bracket I made and stuff. That's really what's making most of the noise. And that belt's tiny. It's not like it's a proper A belt or a B belt. It's just a little tiny belt. It's the same belt that was on the drill press itself. But the old timers used to take a rope, wrap it around the shaft of the motor, give it a yank like they were pole starting something, and it was enough to get it going. I'd rather not do that. So let's see, turn our power back on. Here we go. We're going to engage the pony motor. Pony motor is engaged. Our idler motor is engaged. I'll let it run for a second. And now for our sample motor. Now it's kind of loud because it doesn't have any load on it. There you go. That's her running, folks. Do it one more time here. There we go, that's her. Works for me. Coffee, where are you? I know you're in here. Who's your daddy, bitch? Okay. I hope you guys enjoyed this couple video series on building a rotary phase converter. We are now ready to get that power hacksaw going. I'm just waiting on some blades. With the pandemic and all that crap, who knows how the hell long they're going to take to get here. Hopefully they ship pretty quick. Hopefully they get here pretty quick. I think they're supposed to be here this week. So I grabbed what I could find for them, and there are plenty available, but I was on a tight budget for this one, but it should be able to get us going. It's going to be the Starrett red stripe blades made for the high carbon steel. That's the big thing, is being able to cut high carbon steel. Like I said in the last video, I'd want to just be able to set it and walk away from it so I can go do other things to keep my production value a little bit higher. So if you're looking to build one of these, I hope this video explains quite a bit. Please keep in mind, you build one, you're liable for it. This has nothing to do with me. I know it sounds stupid to have to say that, but stupidity is a staple in this modern world sometimes, it seems. Just, I don't know, it just seems to be that way. A lot of nutsacks out there doing nutsacky things. So, anyway, if you're not comfortable with electrical work, don't build it. If you don't know much about three-phase and how it works, don't build it. You don't know much about capacitors, run capacitors, don't build it. There, I've done my part to protect humanity against stupidity. But if you do have some mechanical sense about you, and you do have some electrical sense, there's nothing to build in one. They are super easy. It's kind of along the same lines. The 2x72 belt grinder was real easy to build. Real simple. It's just people overcomplicate the shit out of everything. Some of you are going to ask, why would you build this rickety thing that's loud and obnoxious and things like that? Well, to buy the same thing that's comparable to that, granted a little bit fancier, no pony motor making the noise, you would need it's something like $600 to $800 depending on what you get for the size of that. For me to get a new motor to replace on that power hacksaw, it's going to be anywhere $400 to $600. I just built this thing for free. I have $24 into a pulley for that 5-horse motor. Other than that, that's built completely out of scrap and stuff I had laying around. Now granted, I'm in the mechanical trades anyway, so I get a lot of this stuff, and fortunately for me, there's not many people out there who have three-phase in their home shops, so it makes it so much nicer if you can generate your own three-phase. That stuff, it opens up an entire new world to you for your home shop. Anything like that. If you could figure out making the power you need, you wouldn't believe how cheap you can get the stuff you want. Three-phase motors are less than half the cost of single-phase motors. And it's crazy. A lot of that is you only find them in industrial applications. If you're going to buy used motors, a lot of times you could get a three-phase motor for 10 to 20 bucks per horsepower. That's pretty good. So it's amazing what you can get used even. If you, how many of your local high schools have you seen that have auctioned off all their shop tools that ended up being three-phase? A lot of times you can't get them because you don't have three-phase power. Well, this is your answer. Like I said, it may seem a little noisy or not as fancy as you would like, but I tell you what, that is a totally safe and functioning system right there. I'm not worried a bit about it. Turn the power off when you're not using it. Be in the building when you're running it. Chances are you'll be just fine. So, I had mentioned that when you run the load on it, the voltage actually cleans up some. I think I showed you guys that on camera. So what happens, you have another induction motor tied into that circuit. So the way that works, I don't have time to explain it all, but the way it works, it actually cleans up your power a little bit. So they say if you're running more than one piece of equipment on a rotary phase converter and you want to run something and your voltage isn't as clean as you want it to be, turn another tool on, let it idle, and a lot of times that will clean the voltage up really well. Now I'm real happy with that. You guys saw the voltage readings under load was really close. The amp draws were really close. It's within that 10% safety range that you have to operate without hurting the equipment. That's what we're looking for. As I said before, a VFD drive is not a good choice for old equipment because the voltage spikes a lot. The older equipment does not have the insulation on the motor windings to handle the heat generated by those voltage spikes. The 2x72 belt grinder we built, that motor has the insulation classified to handle those voltage spikes without any issues. So anyway, I hope you guys enjoyed this one. I'm going in to edit this, I'm going to bed, and I will see you guys on the next one.